Hello everyone. Today we're going to look at volumes by integration. So what we're going to do is we're going to have an area that is up against either the x or y axis, and we're going to rotate it around either the x or y axis. Depending on where the area is and what axis we're revolving around, we'll use one of two methods. The first method is called the disk method. We use this method if the area that we're revolving is touching the axis we are revolving around. In both cases, if the area is against the x-axis, we integrate over x. If the area is against the y-axis, we integrate over y. Just like with the areas, we have to remember that if we're integrating over y, we need to make sure that our integral is in terms of y and not x. So here's our first example. We're going to rotate the area bounded by y equals x squared, x equals 2, and the x-axis over the x-axis. So generally, I will draw a little arrow here to indicate that I'm revolving around the x-axis. Okay, so the area is up against the x-axis, which is the axis we're revolving around. So that means we're going to use the disk method. And here's kind of a 3D picture of what this guy looks like. So as you can see, here is the equation again. It's being revolved around the x-axis, and then we have this solid that's generated. So the equation for the disk method is, if we're doing it in x's, then it's pi times the integral from a to b of f of x squared dx, or if it's in terms of y, pi times g of y squared dy. This comes from the equation for a cylinder, which is pi r squared h. So we have the pi, our r is our function, so we're squaring it, and then h is our dy or our dx. Okay, so this is exactly from the formula for the volume of a cylinder. So our equation, our area here is again up against the x-axis, which means that we're integrating in terms of x. So we have this one. Everything is already in terms of x, so that's really nice. So our equation is pi times the integral from 0 to 2, right? 0 up to 2, and we're given the 2, of our function, x squared squared. So we're going to square our square, which gives us pi times the integral of x to the 4th. So remember, you multiply your exponent, so it's because 2 times 2 is 4 that we're getting x to the 4th. And again, just like with the area, I'm not going to focus on how to do the integration. We know how to integrate x to the 4th, so I'm not going to spend time on that. What I want you to do is pause the video, do it out yourself, and make sure you're getting the same thing. And hopefully you get 32 pi over 5. So for all of these, you always have a pi. Make sure you're leaving your answer in terms of pi. So don't plug this into your calculator and come up with a decimal. Leave the pi in there. So you're just going to do this guy, get 32 over 5, and then multiply by pi. So let's try another one. Find the volume determined by rotating an area bounded by y equals x squared, y equals 4, on the y-axis over the y-axis. So it's the same equation, y equals x squared, but instead of this area down here, which is what we just did, we now have the area in yellow, which is up against the y-axis. And again, we're revolving around the y-axis. So again, the area is up against the axis we're revolving around, so that means we're using the disk method. Again, here is kind of a picture of what it looks like. So again, our function is up against the y-axis, which means we're doing our integration in terms of y. So we have to solve this equation for x. So we need it to be x equals something of y. So we're going to square root both sides. And again, remember that in general, you end up with the square root, you end up with plus or minus the square root of y. But A, we've got the positive side. So I know I want the positive square root of y. And B, we're going to square it anyway, so it doesn't really matter. So I could do plus or minus square root of y, because once I square it, it's going to become positive. Okay, but just remember, in some cases it does matter which one you're using. But in this case it doesn't, because we're going to square it anyway. So we square our square root, we get the original function back. So we're just doing pi times the integral from 0 to 4, remember our y values, from 0 to 4 of y dy. And again, this integration is really easy, and you should be getting 8 pi. Let's take a look at the second method, which is called the shell method. So we use the shell method if the area we're revolving is not against the axis of revolution. But again, just like with the disk method, whatever axis the area is up against, that's the variable we're going to integrate across. So the shell method looks a little bit different. It is 2 pi times the integral of the variable times the function. Okay, so either x times f of x if you're doing it in terms of x, or y times g of y if you're doing it in terms of y. And this comes from the volume of what's called a shell, which is basically a cylinder with a hole in the middle. Okay. So this is where it's coming from versus just the cylinder that we had in the disk method. So a shell method, there's like a hole in our cylinder, or it's sometimes called the washer method. Okay. So as our first example, again, we have the same function as the last two, y equals x squared. And again, this one is between x equals 2 and the x-axis. But now we're going to revolve it around the y-axis. So the area is up against the x-axis, but we're revolving around the y-axis. So they're two different axes, which means we're going to use the shell method. Again, here's kind of a picture of what it looks like. So the area here is the solid kind of outside part of this. So there's a hole right here. It's a hole inside of there. Kind of like a bowl with a cylinder on the outside of it. It's kind of hard to tell sometimes, so I'm doing my best here with these pictures. But again, the area is up against the x-axis, so we're going to do our integration in terms of x. And again, it's 2 pi times the integral from 0 to 2 of my variable times my function, dx. I'm going to simplify that. And then again, the integration itself is very easy. And I should be getting 8 pi. So most of this is just determining which method and which variable to use. So again, on the test you'll be given the equation, so you just have to know when to use which one. So there are really 4 possibilities. There's the disk method with x's, the disk method with y's, the shell method with x's, the shell method with y's. So you got to know when to use each one. So for our next example, it says find the volume of the area bounded by y equals x squared, y equals 4, and the y-axis. Again, the same exact one we used 2 examples ago, except now it's revolved around the x-axis. So the area is up against the y-axis. We're revolving around the x-axis, which means we're using the shell method, and we're using the y variable. Again, here is kind of a picture of what it looks like. Again, it's kind of like that bowl picture we saw earlier, but on its side. So it's solid on the outside, and there's a hole here in the middle. And that hole is where the shell method comes into play. Okay, so again, we know it's the shell method because the area is not against the axis of revolution, and we know we're doing y's because the area is up against the y-axis. So that gives us 2 pi times the integral from 0 to 4 of our variable times our function, and again, we need to rewrite this in terms of y. So y equals x squared becomes x equals the square root of y. And again, for the same reason as before, it's the positive square root, and not the negative. So I'll clean that up. Y times the square root of y is y to the 3/2. Again, the integration is really nice. It's just the power rule. And hopefully you're getting 128 pi over 5. Okay, so again, this is, I'd say 60% setting it up, 40% doing the actual integration, which most of the time will just be the power rule. Not all the time, but most of the time. Okay, so now I'm not going to tell you right away if it's the disk method or the shell method. So before we did 2 disks, then we did 2 shells, so now I'm going to mix it up a little bit. We're going to see both of them. So we're going to figure out which one do we have to use. So find the volume of the area bounded by y equals 2x, y equals 6, and the y-axis revolved around the y-axis. So I'm going to draw a little arrow here. So I'm revolving around the y-axis. So we need to determine two things. A, which method, and B, which variable. So no matter which method it is, we know that it's going to be the y variable because it's up against the y-axis. So I know right away it's the y variable. And now I have to ask myself, is the area up against the axis of revolution? If the answer is yes, it's the disk method. If the answer is no, it's the shell method. So in our case, it is up against the axis of revolution. So it's going to be the disk method in terms of y. And again, just for a little bit of clarity's sake, here's what the picture would look like. Okay, it's a cone. We don't even actually need to do integration to find the volume of a cone. We have a nice formula for that, but we're still going to do this out. But just know that it is actually a cone. So as we mentioned, it's the disk method. Again, it's in terms of y, which means I take my y equals 2x and solve it for x. So x is y over 2. So I have pi times the integral from 0 to 6, again my x values, y over 2 squared. Make sure you're squaring both the y and the 2. We have y squared over 4. I'm going to pull the 4 out because it's just a coefficient. So I have pi over 4 times the integral from 0 to 6 of y squared dy. Again, the integration, very easy. You should be getting 18 pi. Which again, if you remember the formula for a cone, you can check very easily. But we won't get into that for now. So here's another example, again very similar. It's the same equation, y equals 2x, but now it's also bounded by x equals 3 and the x-axis. And we're revolving still around the y-axis. So instead of the area above the line, we've got the area below the line. Again, here's what the picture would look like. And again, notice it's the outside part, so there's a hole in the middle here. So it's the outside part of the cone. So, again, we have to decide, is it disks or shells, and is it x or y? So it is up against the x-axis, which means our variable is x, and it is not the axis of revolution, which means it's shell. So it's shell because it's not the axis of revolution. It's x because the area is up against the x-axis. So we have 2 pi times the integral from 0 to 3, so the x values, our variable x, our function 2x, and then dx. Again, I'll clean it up. I'll bring the 2 outside to make it 4 pi. X times x is x squared. And then again, the integration itself, fairly straightforward. And we should be getting 36 pi. Let's try another one. Still y equals 2x. Still, in this case, x equals 3 and the x-axis. But now we're revolving it around the x-axis. So now we're going this way. And again, here's a picture. Still a cone, but now it's a different cone than it was before. And it's also kind of a cone on its side. Okay. So, just like before, the area is up against the x-axis. So we'll be doing the x variable. And this time, the axis of revolution is also the x-axis, which means we'll be doing the disk method. So we have pi times the integral of 0 to 3, again the x values, of our function being squared. So again, don't forget you have to square both the 2 and the x. And again, I'll pull the 4 out. So we have 4 pi times the integral from 0 to 3 of x squared dx. Again, integration, very easy. And you should be getting 36 pi. So let's do the last one. Still y equals 2x, the last one of this type anyway, not the last one for the video. So still y equals 2x, but now again it's the top part. So it's from y equals 2x to y equals 6 and against the y-axis. And again, we're revolving it around the x-axis this time. So this is all 4 possibilities using the equation y equals 2x. So here's what it looks like graphically. Again, it's the outside part of that cone. So it's basically a cylinder with a cone taken out of it. So we have this emptiness, this hole right here. Okay. Our area is up against the y-axis, which means we'll be doing everything in terms of y. And again, that means we need to solve this for x so that it's in terms of y. The axis of revolution is not the axis the area is up against, so that means we're doing the shell method. Again, anytime you see this hole, and that's because of this area here, where we're going to get the hole, that's the shell method. So we get 2 pi times the integral 0 to 6, again the y values, our variable y, times our function, which again in this case is x equals y over 2, and then dy. So again, you have to make sure everything's in terms of y in this case. The 2's cancel, and I'm left with pi times the integral from 0 to 6 of y squared dy. Again, very easy to integrate, and we get 72 pi. Okay. Now let's try something different. Find the volume of the area bounded by y equals 4 minus x squared, the x-axis and the y-axis revolved around the y-axis. So we're revolving around the y-axis. So again, this is what it looks like. And I'll put the little mark there. Okay. So we need to figure out, again, which method and which variable. So notice my area is up against both axes. It's up against the x-axis, it's up against the y-axis. That means that I can do either method. And then depending on the method, that's going to determine which variable I'm going to use. So I'm going to set them up both ways. And then again, I want you to make sure that you're doing the integration and that you get the same answer either way. So let's start with the disk method. The disk method is assuming that the area is up against the axis of revolution. In this case, the axis of revolution is the y-axis. So I'm going to assume that the area is up against the y-axis, which means that I'm doing everything in terms of y. Okay, so my first step is to change my equation to be in terms of y. So if y equals 4 minus x squared, then x equals the square root of 4 minus y. Okay, again, I'll subtract the 4, divide by -1, and then square root. And again, I want the positive square root because I'm over here in the positive quadrant 1, basically. So I do want the positive square root. Okay, so I get pi times the integral of 0 to 4 of the square root of 4 minus y squared dy, so that's the disk method. Again, the square and the square root will cancel. So I've just got pi times the integral from 0 to 4 of 4 minus y dy. Again, a very nice, easy integration to do. Then you should be getting 8 pi. The other thing we can do is the shell method. So if I want to do the shell method, and again, this is revolving around the y-axis, so the shell method is assuming that the area is up against the other axis. So we're assuming the area is up against the x-axis, which means that my variable is x, which is nice, means I don't have to rearrange my equation at all. And I have to do the shell method, the shell formula. So 2 pi times 0 to 2, again, 2 was the x value, right? 4 was the y value. So 2 pi, the integral 0 to 2 of my variable, which is x, times my function, which is 4 minus x squared dx. Distribute the x before you integrate, right? You have to do that first. And then again, it's just the really nice power rule, and you should still be getting 8 pi. Doesn't matter which method you do, you should be getting the same answer because it's just one volume. So as our last example, we're going to find the exact same area, but now revolved around the x-axis. So how is that going to change it? So there's a picture of it, and it looks similar to what we had in the first example, except sideways and slightly different shaped, right? It's not symmetric, so it is going to be a little different. But again, the area is up against both axes, so we can do either method. So this time, if I want to do the disk method, again, that's assuming the area is up against the axis of revolution. So the axis of revolution in this case is the x-axis. So I'm going to assume that my area is up against the x-axis, which means that my variable is x. So in the last example for the disk method, my variable was y. Now my variable is x. That's the nice one. Again, I don't have to rewrite my formula at all, so it's just pi times my function squared. Again, make sure that you're squaring it out and simplifying before you start integrating. So we get the integral from 0 to 2 of 16 minus 8x squared plus x to the 4th dx. Again, fairly easy to integrate. You should be getting 256 pi over 15. Okay. The next one is the shell method. So we'll see how this one's a little different. So the shell method, again, is assuming that your area is up against the other axis. So in this case, it'd be the y-axis. So we need to make sure that everything is in terms of y. So again, we have to let x equal the square root of 4 minus y. So in the shell method, we then have 2 pi times the integral from 0, that 2 should be a 4, and the y value. So 2 pi times the integral from 0 to 4 of our variable times our function, so y times the square root of 4 minus y dy. Now, in order to do this integration, we would have to do by parts. Okay, I can't just do a u substitution because that won't get rid of the y out front. So I would have to do by parts. So I'm not going to do it out right now, but again, I want you to try it. Don't forget that in by parts, you want to go through your LIPET. Which one do you want to do first for u? Which do you want to do for v? So for this one, I would suggest letting u be y and letting dv be everything else. So the square root of 4 minus y dy. And that should be a fairly easy u substitute, fairly easy by parts equation. But you do have to do by parts. So in this case, I would definitely suggest doing the disk method if you had to do just one of them. Okay, but again, you should be getting 256 pi over 15. Okay. So read through the section, try out some of the homework, and let me know if you have any questions. Thanks.